Okay, so I guess we will be starting now. Mm, Right. Some are still coming. All right, so let's start. So good evening, everyone, and a heartiest welcome to the today's TechWeek session presented by IEEE DTU. So we second year students of IEEE will be hosting a presentation on the topic data structures and algorithms. So we will be covering most of the important topics in data structures and algorithms. So before that, please allow me to introduce myself. My name is Ankush Bhagat from COE branch, second year. And I've been in IEEE for the past 1 year as a PR team member as well as a web developer. So yeah, and yeah, if you have any doubts, feel free to write your doubts in the chat box. So let me share my screen. I hope the screen is visible. All right. So yeah, so before studying data structures, first of all, we need to know that why we are studying data structures. So basically, computer science is all about storing and computing data. So data structures helps in maintaining and storing those data efficiently, and algorithms are the ones which are able to store those data efficiently and make them faster. So the collection of basically algorithms are based on data structures in one way. So these are some of the elementary data structures that we will be covering in today's presentation. Arrays, then this is linked list, this is stacks, queues, and trees. So the first data structure, which is the most basic one, is array. So array is a collection of items stored at contiguous memory locations. So the idea here is to basically store multiple items of the same data type. The data type can be int, float, double, character, etc. So just have a look at this picture. So as you can see, यहाँ पे हमें एक array दे रखा है, which is of length 6, 1, 2, 3, 4, 5, 6. And the indexing of the array always starts from 0. So the end element index will be 5. So what is this ARR of 0? So this is basically how we access a particular element in an array. So ARR of 0 is basically accessing the first element of the array. That is the element which is present at the 0th index, right? This ARR is basically the array variable name. कुछ भी हो सकता है, int, float, double जो data type है, अगर ये int का भी array हो सकता है, double का भी array हो सकता है, and variable name तो it can be anything. But just remember that ये जो square brackets के अंदर जो आएगा, that will be the index of the element which we want to access. So there are some fundamental techniques on arrays. We have searching and sorting. So today we will be discussing only searching. So first type of searching is linear search. So by the name itself, you will be able to guess what it is. So basically the idea is, if we have an array and we want to search an element, for example, let's say 33. All right. So what we do is we traverse the whole array from the left, because from the first index we traverse the whole array and we check whether 33 is present in the array or not. So see in the animation, as you can see, 33 is compared with 10, then 14, then 19, and it is compared until we don't find a match. Once a match is found, we just return the index. Otherwise, we just return -1, or we can just print that the element is not found. So this is basically the algorithm. So क्या हो रहा है यहाँ पे? We have a for loop. Loops का idea basic programming में पढ़ा होगा कल. So loops, basically we are running from I is equal to 0 and I is less than n. What is n here? So n is basically the length of the array, right? सो हम फिर चेक कर रहे हैं ये इफ एल्स कंडीशन में हम चेक कर रहे हैं कि ARR ऑफ i इज इक्वल टू x। अगर x मिल जाता है तो हम वो रिटर्न i, दैट इज हम वो पोजीशन रिटर्न कर देते हैं कि इस पोजीशन पे हमें एलिमेंट मिल गया। अगर नहीं मिला तो हम एंड में लूप के बाहर हम रिटर्न -1 कर देते हैं, विच जस्ट सिग्निफाइज कि हमें एलिमेंट नहीं मिला। तो व्हाट इज दिस टाइम कॉम्प्लेक्सिटी? टाइम कॉम्प्लेक्सिटी यहाँ पे लिखी है बिग ऑफ n। सो टाइम कॉम्प्लेक्सिटी ऐसे मान लो कि बेसिकली जो एल्गोरिथम है उसको कितना टाइम लग रहा है एग्जीक्यूट होने में। अब ये जो बिग ऑफ n है इस पे ज्यादा डिटेल में जाने की जरूरत नहीं है, बस यहाँ पे n देखो। n मतलब लीनियर, सो बेसिकली जो हमने लूप चलाया था दैट इज फ्रॉम 0 टू n, राइट? n लेंथ का था, तो दैट इज डिपेंडिंग ऑन n। सो बेसिकली हम कह सकते हैं कि जो टाइम है दैट इज डायरेक्टली प्रोपोर्शनल ऑन n। सो कैन वी ऑप्टिमाइज दिस अप्रोच फर्दर? So the answer is yes, we can use binary search here. So क्या होता है बाइनरी सर्च में? सेम वी हैव एन अरे गिवन, बट यहाँ पे important factor is the array is sorted. Sorted means that the array is in ascending order, that is in increasing order. So you can see every element is less than its next element, right? And indexing as I said 0 से होती है, तो 0 1 2 3 4 till 9। एंड अगर लास्ट इंडेक्स 9 है तो अरे का लेंथ क्या हुआ? 10, राइट? सो अगर मान लो हमें 23 सर्च करना है, राइट? सो अगर 23 सर्च करना है तो हम क्या करते हैं? वी कीप टू वेरिएबल्स l and r, h, लो एंड हाई। लो जो है दैट विल बी पॉइंटिंग टू द फर्स्ट एलिमेंट, दैट इज द फर्स्ट इंडेक्स, एंड जो हाई है वो एंड इंडेक्स को पॉइंट करेगा, दैट इज द लास्ट एलिमेंट ऑफ द अरे। अब बाइनरी सर्च में क्या प्रिंसिपल है कि वी डिवाइड द अरे इनटू टू हाफ्स। तो इस अरे को अगर हमें स्प्लिट करना है हाफ में तो हम क्या करते हैं? हम लो प्लस हाई डिवाइड बाय 2 करेंगे, तभी तो हमें उसका मिड पॉइंटर मिलेगा, राइट? सो वी डिवाइड दिस अरे इनटू टू पार्ट्स, लेफ्ट, सो दो पार्ट आ जाएंगे, एक लेफ्ट रीजन होगा एंड एक राइट रीजन होगा। एंड जो भी मिडिल एलिमेंट होगा, जैसे हमने यहाँ पे करा 0 प्लस 9 डिवाइड बाय 2, तो 0 प्लस 9 डिवाइड बाय 2 4.5 होता है। एंड हम उसका लोअर वैल्यू लेते हैं, लाइक राउंड डाउन करते हैं, तो 4 आ जाएगा। अब 4 पे कौन सा एलिमेंट है? 16। तब हम चेक करते हैं कि जो 23 है वो 16 से बड़ा है, छोटा है या इक्वल है। ये तीन चीजें हम चेक करते हैं, बड़ा, छोटा या इक्वल। अब यहाँ पे देखो 23 इज ग्रेटर देन 16, इसका मतलब क्या हुआ? मतलब ये अभी 16 से बड़ा है, तो इसका एक ही सीधा सेंस निकलता है कि द 23 विल बी लाइंग ऑन दिस रीजन, राइट? बिकॉज इस रीजन के एलिमेंट्स तो पहले से छोटे होंगे 23 से, बिकॉज ये अरे क्या है? सॉर्टेड। तो यहाँ पे दैट सॉर्टिंग थिंग वर्क comes in handy. So 23 will be lying in this region. So फिर हम अपना लो पॉइंटर जो है वो अपडेट कर देते हैं 4 पे, राइट? सो हम फिर इस एलिमेंट दैट इज 23 38 56 72 91 इसमें चेक करते हैं। एंड देन अगेन सेम प्रोसीजर, हम इस तरह को डिवाइड करते हैं। लाइकवाइज हम सेगमेंट्स में डिवाइड करते रहते हैं until we find our desired element. एंड जब मिल जाता है तब हम return 5, that is we just return the index of that element. So this is the algorithm for binary search. So ये अरे है, हम ऐसे अरे पास करते हैं। L हमारा जो मैंने कहा था लो, and R is our right index, that is high. और जो X है that is the element that is to be searched in the whole array. So what we do is we use a loop, while loop, L is less than R. Obviously जो हमारा लेफ्ट पॉइंटर है वो राइट पॉइंटर से तो आगे नहीं जा सकता ना, नहीं तो गड़बड़ हो जाएगी। तो हमें लेफ्ट पॉइंटर को राइट पॉइंटर से कम ही रखना है। एंड m जैसा मैंने कहा हम डिवाइड करते हैं, दोनों इंडेक्स के बीच हम मिड पॉइंट निकालते हैं। एंड देन इफ द वैल्यू एट द मिड पॉइंट इज इक्वल टू x, तो हम बेसिकली रिटर्न m, दैट इज वी जस्ट रिटर्न द इंडेक्स ऑफ दैट एलिमेंट। एंड अगर जो x है इफ दैट इज ग्रेटर देन ARR ऑफ m, देन हम लो पॉइंटर को इंक्रीमेंट कर देते हैं m+1, अदरवाइज हम राइट पॉइंटर को डिक्रीमेंट कर देते हैं। तो ये बेसिकली एक सिंपल कोड है बाइनरी सर्च का। अगर एलिमेंट नहीं मिला, जस्ट लाइक लीनियर सर्च, हम रिटर्न -1 कर देते हैं। अब यहाँ पे टाइम कॉम्प्लेक्सिटी ऑफ log n है, ये o तो रहने दो, log of n, दैट इज द मेन थिंग। अब व्हाट इज log of n? यहाँ पे log of n क्यों आया? लीनियर सर्च में हमने पूरा का पूरा एलिमेंट ट्रैवर्स करा था, राइट? टू सर्च फॉर अ पर्टिकुलर एलिमेंट हमने पूरा का पूरा चेक करा था हर एक एलिमेंट से कि क्या ये एलिमेंट इक्वल है कि नहीं। बट बाइनरी सर्च में हम क्या कर रहे हैं? हम अरे को डिवाइड कर रहे हैं, राइट? सो एक लॉगरिथमिक फंक्शन बन रहा है। हम हर एक इंटरवल पे इसको डिवाइड करते जा रहे हैं, जब एंड जैसे ही एलिमेंट मिल रहा है हम उसको रिटर्न कर रहे हैं। इसलिए यहाँ पे आया है कि बाइनरी सर्च की जो टाइम कॉम्प्लेक्सिटी है दैट इज प्रोपोर्शनल टू log n। अगर लाइक इससे क्या फायदा है वो हम इस टाइम ग्राफ से समझ सकते हैं। तो हमने देखा था लीनियर सर्च पे कि डायरेक्टली प्रोपोर्शनल टू n है। इसका मतलब कि वो एक स्ट्रेट लाइन है, y इज इक्वल एरे पे डिपेंड कर रहा है, तो एक स्ट्रेट लाइन बन जाएगी ये रेड कलर की लाइन। एंड जो बाइनरी सर्च का हमने देखा था दैट इज log of x, राइट। सो y इज इक्वल टू log of x का ग्राफ कुछ ये ग्रीन लाइन बन जाएगी। तो यू कैन योरसेल्फ सी कि कितना डिफरेंस आ जाता है अगर हम हायर वैल्यूज लेंगे। फॉर एग्जांपल एट दिस पॉइंट पे जो बाइनरी सर्च है दैट विल टेक ऑब्वियसली लेस टाइम देन लीनियर सर्च। लीनियर सर्च विल टेक डबल द टाइम ऑफ बाइनरी सर्च। सो इसीलिए algorithms are important and that's why arrays searching is getting optimized. Next data structure is list. So we have linked list here. So a linked list is a linear data structure in which the elements are not stored at contiguous memory locations. Array में they used to store at contiguous memory locations, right? The elements in a linked list are linked using pointers as shown in the below image. अब ये जो contiguous memory location है इसका क्या मतलब है? मेमोरी लोकेशन बेसिकली कि हम अरे में जब अरे क्रिएट करते हैं तो हम बेसिकली हर एक मेमोरी में एक एलिमेंट स्टोर कर देते हैं। बट लिंक लिस्ट में ऐसा नहीं होता। लिंक लिस्ट में एलिमेंट्स गेट्स लिंक्ड। यहाँ पे आप देखो दिस इज अ node has a data and a next. So what is this next? So next is basically a pointer which is pointing to the next node. So basically chain type formation हो रही है and ये head pointer है। आप इसको like ट्रेन की जैसे समझ सकते हो। you must have seen train। तो ट्रेन में क्या हो रहा है कि ये जो फर्स्ट नोड है ना दैट इज हम उसको इंजन का समझ सकते हैं। इफ यू वांट टू गो टू एनी कोच ऑफ द ट्रेन हमें इस कंडीशन में इंजन से ही जाना पड़ेगा। लाइक क्योंकि हम ऑब्वियसली हम डायरेक्ट तो जा सकते हैं, डिब्बे पे डायरेक्ट जा सकते हैं, बट अभी हम अज्यूम करेंगे कि हमें स्टार्टिंग के इंजन से ही जाना पड़ेगा। सो दैट इज व्हाट इट इज। हमें अगर हमें बी पे जाना है तो हमें पहले ए पे जाना पड़ेगा एंड देन ए से ये नेक्स्ट पॉइंटर की हेल्प की वजह से we will go to B. Likewise, we will traverse this linked list. And end is null, that is it's not storing anything. So that is the end of the linked list. So we have singly linked list. So a singly linked list is defined as all nodes are linked together in a few sequential manner. Singly linked list का basically यही मतलब है कि we have one node and that is linked to every other next node. जो हमने पिछली स्लाइड में डिस्कस करा that is singly linked list. So हम इसको डिक्लेयर कैसे करते हैं? दिस इज द कोड फॉर डिक्लेरेशन। स्ट्रक्ट वगैरह ये समझ जाओगे आप जब पढ़ोगे। ठीक है, तो यहाँ पे मेन चीज ये है कि इन डेटा जो नोड है उस पर हम डेटा स्टोर कर रहे हैं एंड जैसा मैंने कहा वी विल बी स्टोरिंग द पॉइंटर टू द नेक्स्ट एलिमेंट। सो दिस इज हाउ वी डिक्लेयर पॉइंटर स्टार नेक्स्ट। एंड ये स्टार हेड है ये बेसिकली कीप ट्रैक रखने के लिए कि वेयर वी आर जो इनिशियली वो स्टार्ट करेगा लिंक लिस्ट के स्टार्टिंग पे एंड ट्रैवर्स करने के लिए हम उसको इंक्रीमेंट करते रहेंगे। Then we have doubly linked list. So a doubly linked list DLL contains an extra pointer typically called previous pointer together with the next pointer and data which are there in the singly linked list. So doubly linked list नाम से पता चल रहा है it's doubled. That means we are able to access both the next as well as the previous element. Now in order to access the next element we need a next pointer, right? So like so same here, if we want to access the previous element we will be needing the previous pointer. So here as you can see we have a node which contains data, the next pointer which will be pointing to the next node and the previous pointer which will be pointing to the previous node. So यहाँ पे बस एक pointer हमें extra add करना that is star pref। तो ये वही same declaration है, बस यहाँ पे हम struct node star pref we just write that extra line to implement doubly linked list. Next data structure is stacks. So a stack is a linear data structure which follows a particular order in which the operations are performed. The order is LIFO, that is last in first out. So इसको हम समझ सकते हैं like if for example books piling on each other, right? हम सबसे पहले बुक रखते हैं नीचे and then उसके ऊपर एक और बुक and उसके ऊपर एक और बुक. Another example could be like construction of a building. So जब बिल्डिंग बनती है सबसे पहला फ्लोर बनता है ग्राउंड फ्लोर, देन उसके बाद फर्स्ट फ्लोर, देन सेकंड फ्लोर, राइट? सो वैसे हम फाइल करते रहते हैं, तो वही सेम कॉन्सेप्ट है यहाँ पे भी स्टैक में। So let's understand that. So operations on stack are push, peak or top, pop, and is empty. So सबको discuss करेंगे in further slides. So first let us discuss the implementation of stack. So there are two ways to implement stack using array. तो अब यहाँ पे अरे में क्या हो रहा है कि if the array is this 12, 8, 21, 33, 18 and 40. तो जैसे जैसे हम अरे को ट्रैवर्सल करते हैं, अब मैंने कहा था कि अरे को ट्रैवर्सल कैसे करते हैं, स्टार्टिंग इंडेक्स से, राइट, 0th इंडेक्स से ट्रैवर्सल होती है अरे की. तो जैसे जैसे हम अरे को ट्रैवर्सल करेंगे, we will keep on pushing the elements into the stack. So 12 will be pushed, that means 12 will be the bottom element. Then 8 will be pushed, then 21, then 33, then 18, and then 40. So 40 will be the top element of the stack. So these are some of the algorithms of different functions. ये बस algorithm है, हम इसको समझेंगे अभी with the help of a basic code of this is the stack code. जो line है stack int s. This is how we implement this data structure, and this is implemented in C++ STL. Okay, and इसको include करने के लिए we have to use a header file #include stack. ये last वाले lecture में पिछले day में हमने पढ़ा था about header files. So यहाँ पे देखो stack int s. So stack का name is s. Now we are pushing s dot push 1. So ये जो s dot push है, what is it doing? It's pushing the first element into the stack. So मतलब first will be the bottom layer, right? Then 4 is pushed on top of it. Then 9, then 16, and then 25. So if we say cout s dot top, cout is used in C++ for printing any value. So s dot top. So this is the top function that I had talked in previous slides. So s dot top, what it will do? It will just print the topmost element of the stack, right? And topmost element कौन सा है? 25, because 25 last में आया था, and जो last में आएगा वो सबसे top में जाएगा. So the output will be for of this will be 25. Now s dot pop, ये pop से क्या हो रहा है? Pop से basically the topmost element gets deleted, right? So अगर हमने s dot pop किया, so whatever is the topmost element, here in this case it was 25, it will get deleted from the stack. Now अगर हम वापस उसको s dot top print करें, अब हम वापस हमें चाहिए कि what is the topmost element of the stack. This time it will be 16 because 25 तो निकल चुका था. S dot empty. So this is a boolean function. ये basically true या false return करता है अगर stack empty है, मतलब stack में कुछ element नहीं है. So it will return true, that is 1. And if the stack is not empty, that means अगर stack खाली नहीं है, तो it will return 0. So यहाँ पे s dot empty, since the stack is not empty, we still have 1, 4, 9, and 16. So our output will be 0. S dot size, the size function, नाम से पता चल रहा है, it will return the size of the stack. So the current size of the stack is what? 1, 4, 9, and 16. बस ये चार एलिमेंट थे. 25 तो हमने यहाँ पे पॉप कर दिया था. एक बार हमने एलिमेंट निकाल दिया, then we can insert back, but वो रहेगा नहीं stack में. We have to use push function again. So s dot size, the output will be 4 since the current size of the stack is 4. So we can implement stack using linked list also. So linked list में जैसा हमने देखा था, we have a node which contains data and next pointer, and there is a head node which will be used for traversal of the linked list. So जब head starting में रहेगा, data will be exist. यहाँ पे 40 है, then 18, then 33. बट यहाँ पे आपने एक बात नोटिस करी होगी कि if this is 40, तो 40 सबसे नीचे आना चाहिए stack के, right? But linked list traversal happens using recursion. So when the last element comes, that is pushed first, and then first element is pushed at the last. Recursion we will be discussing today later. So this is the stack summary and the different operations that we discussed: pop, push, top, size is empty. ये जो O1 ये हमने O पहले भी देखा था टाइम कॉम्प्लेक्सिटी के टाइम पे लीनियर सर्च एंड बाइनरी सर्च में. तो the 1 basically represents constant time. यहाँ पे हम कुछ ट्रैवर्सल वगैरह नहीं कर रहे हैं, ना कुछ वो कर रहे हैं, तो basically it takes constant 1 time. Worst cases it might happen that it becomes ON because of continuous pushing of elements. Then we have queues. So a queue is a linear data structure which follows a particular order in which the operations are performed. The order is first in, first out. ये order is important है. Stack का क्या था? LIFO, last in, first out. This is फर्स्ट इन फर्स्ट आउट, दैट इज फीफो। सो फर्स्ट इन फर्स्ट आउट का मतलब ये समझ लो कि लाइक जो पहले आएगा वो सबसे पहले निकलेगा, राइट? So let us discuss. So example, a good example of a queue is any queue of consumers for a resource where the consumer that comes first is served first. So example हम मूवी टिकट काउंटर पे ले सकते हैं। So क्या होता है, अगर टिकट लेने जाना रहता है तो we form a line, right? एक queue basically is line, right? तो एक लाइन लगती है, क्यू लगती है, and the person who comes first, जो भी सबसे आगे होगा उस लाइन में, उसको सबसे पहले टिकट मिलेगी, राइट? एंड जो सबसे लास्ट होगा उसको सबसे लास्ट में टिकट मिलेगी, एंड जो सबसे आगे होगा दैट इज द फर्स्ट एलिमेंट, तो उसको टिकट मिलेगी तो वो सबसे पहले लाइन से निकलेगा। ऐसा होता है, राइट? तो वैसे सेम चीज क्यू में इंप्लीमेंट हो रही है। तो दिस इट विल कंटेन एन एलिमेंट, एंड जो सबसे आगे होगा उसे हम फ्रंट के नाम से कहते हैं, जो सबसे एंड में होगा उसे हम बैक के नाम से कहते हैं। So these are some of the operations on queue. Push, pop, सेम जो ऑपरेशन हम स्टार्ट में डिस्कस कर रहे थे, पुश पॉप, यहाँ पे भी सेम, दे हैव सेम वर्क, बट यहाँ पे फ्रंट एंड बैक होता है। फ्रंट एंड बैक बेसिकली मींस जो भी क्यू के फ्रंट में है, जैसे मैंने बोला यहाँ पे फ्रंट, तो दिस इज फ्रंट एंड दिस इज बैक और रियर। जब हम इंसर्ट करते हैं ना क्यू में, इंसर्ट ऑब्वियसली लाइन में हम बीच में तो कोई बंदा आ नहीं सकता, राइट? तो इंसर्ट एट मिडिल पॉइंट इज नॉट अलाउड इन क्यू, नीदर इट वाज अलाउड इन स्टैक। स्टैक में भी जब हम इंसर्ट कर रहे थे, बेसिकली पुश कर रहे थे एलिमेंट को, तो वो टॉप मोस्ट में जा रहा था, हम बीच में नहीं डाल पा रहे थे उसे। सेम चीज क्यू में भी हो रही है, सेम। और डिलीट भी नहीं होता, डिलीट हमें जो पहला सबसे आगे होगा वो जब तक निकलता नहीं है लाइन से तब तक तुम खुद सर्व नहीं होगे, राइट? सो डिलीट स्टार्टिंग से ही होगा। एन एम्प्टी साइज, ये सेम फंक्शन जो क्यू स्टैक में थे, यहाँ पे भी इनकी सेम मीनिंग है। सो वो एल्गोरिथम्स हैं these. So let us discuss the operations on queue with the help of basic code. So यहाँ पे queue को implement करने के लिए हम बस ये queue लिख देते हैं, queue line word, this line, and header file will be hashtag include queue, arrow brackets में. So queue dot push 1 4 9, जो सेम एलिमेंट्स हमने स्टैक में पुश करे थे, लेट अस टेक दोस एलिमेंट्स ओनली, 1 4 9 16 and 25. Now stack में क्या होता था कि 1 4 9 they were pushed on top of each other, right? In queue it is going to be in a horizontal fashion. So 1, then उसके पीछे 4, then उसके पीछे 9, then 16 and then 25. So जब हम queue dot front कह रहे हैं, cout queue dot front function, obviously जो सबसे फ्रंट पे होगा क्योंकि स्टार्टिंग में, that will be the output, right? So इसमें इस केस में starting is 1, so output will be 1. Q dot pop, pop basically deletes the frontmost element in the queue, so 1 will get deleted and q will now only be 4 9 16 and 25. Again अगर हमने q dot front किया तो इस बार 4 स्टार्टिंग में है तो 4 प्रिंट हो जाएगा। q dot empty, सेम चीज, अगर q हमारी empty है, फिलहाल तो नहीं है, राइट? अगर नहीं है तो हम फिर आउटपुट 0 कर देंगे, बट इफ द क्यू इज एम्प्टी तो आउटपुट हमारा 1 आएगा, और यहाँ पे नहीं है तो आउटपुट इज 0. Q dot size will basically return the present size of the queue, which is 4. So ये array implementation of queue जैसे stack में होता था वैसे we here traverse the array, and as soon as we get an element we push it into the queue. So same चीज यहाँ पे भी हो रही है, and वही same चीज linked list में head node होता था जो start of the linked list point करता था, जैसे जैसे linked list traverse होती है हम queue में push करते रहते हैं, but since जैसा मैंने कहा recursion होता है linked list में, जो लास्ट एलिमेंट होगा वो सबसे पहले पुश होगा क्यू में, तो वो फ्रंट मोस्ट एलिमेंट होगा क्यू का। सो एप्लीकेशंस ऑफ क्यू देखे जाए तो डायरेक्ट एप्लीकेशंस आर वेटिंग लाइंस, एक्सेस टू शेयर रिसोर्सेज, इनडायरेक्ट एप्लीकेशंस आर ऑक्सिलरी डेटा स्ट्रक्चर फॉर एल्गोरिथम्स एंड कंपोनेंट ऑफ अदर डेटा स्ट्रक्चर। यहाँ पे क्यूइंग मॉडल थियरी भी आती है व्हिच यू विल बी हैविंग इन योर coming semester, so that is also an important application of queue. So the next thing is implementing stacks and queues with DQs. So DQ एक अलग डेटा स्ट्रक्चर है, so basically stacks and queues का मिक्सचर है DQ, हम ऐसे समझ सकते हैं। DQ में क्यू में क्या हो रहा था कि फर्स्ट एलिमेंट, अगर हम नया एलिमेंट पुश करते हैं तो द फर्स्ट एलिमेंट के पीछे जा रहा था वो, राइट? DQ में हम उसको पीछे भी डाल सकते हैं, आगे भी डाल सकते हैं, so अलग अलग, एंड सेम चीज अगर निकालना है तो हम उसको पीछे से भी निकाल सकते हैं, आगे से भी निकाल सकते हैं। तो अगर हम DQ की इम्प्लीमेंटेशन को स्टैक की तरह से देखें तो स्टैक में जो टॉप फंक्शन होता था वो DQ में हमारा लास्ट हो जाता है. पुश पॉप सेम चीज वही यहाँ पे कंटिन्यू होती है. So now I would like to invite my friend Siddhant for continuing with this data structure presentation. So Siddhant, are you there?
Yes, I'll take it from here.
Yeah, okay.
So I'm presenting my screen. So I hope my screen is visible. So hello everyone, I'm Siddhant Khanna, a second year COE student. Like Ankush, I have also been a part of IEEE for 1 year. So let's start with the tree data structure. So the data structures which we have discussed till now, stacks, queues, arrays, and linked lists, were all linear data structures. The data was stored in them in a linear and sequential manner. The data structure which we will discuss now is trees. Trees is a nonlinear data structure used to store hierarchical data. The structure of tree data structure is quite similar to that of actual trees. In trees, we have the root at the bottom and the tree branches towards the top, right? But in tree data structure, we have the root at the top and the tree branches downwards. So to visualize the tree data structure, we can think of it as an inverted tree. Technically, a tree data structure is a collection of nodes such that each node of the tree stores a value, a list of reference to the nodes. In case of a linked list, the nodes had one field to store the data and another field to store a link to the next node, right? But in case of trees, we have multiple next nodes, so we call them children. So in case of a tree, a node has a single field to store data and the remaining field to store links to the children. So here we have the hierarchy in a company represented using trees. So basically here, the data for each node is the name of the employee and these arrows represent links to children. So in this way, hierarchy can be represented using trees. So let us go over certain terms associated with trees. The root. The first node of the tree is known as the root node. Just as in a linked list, if we have a link to the head of the list, we can access all the links. We can access all the nodes of the linked list, right? Because each node has a link to the next node. Similarly, if we have a link to the root node, then we can access all the nodes of the tree. As I told you, each node has a link to its children, right? So in this way, a parent-child relationship is established in trees. So for example, node number 2 has links to nodes 4, 5, and 6. So node 2 is the parent of node 4, 5, and 6, and nodes 4, 5, and 6 are the children of node 2. Siblings. As many of you might have guessed it already, the nodes having the same parent are known as siblings. So nodes 4, 5, and 6 have the same parent too, so they are siblings. Leaf nodes. The nodes having no children are known as leaf nodes. So nodes 4, 9, 10, 11, and 8 are leaf nodes. So in case of leaf nodes, the fields which were used to store links to the children, we can set them to address 0 or null. So these links are unidirectional, right? Node, for example, node 1 has a link to node 2, but node 2 doesn't have a link back to node 1. So if we can travel through these links from a node A to a node B, then an ancestor-descendant relationship will be established between them. So for example, we can travel from node 1 to node 9, right? We can move from node 1 to node 2, then from node 2 to node 5, then from 5 to 9. So node 1 is the ancestor of node 9, and then node 9 is the descendant of node 1. Similarly, we can walk from 2 to node 9 also, right? So 2 is also the ancestor of 9. So here's an exercise for you guys. So you have to tell me the common ancestors of nodes 4 and 9. You can type your answers in the chat box. I'll give you 5 seconds, then I'll tell the answer. So the ancestors of node 4 are nodes 1 and 2, and the ancestors of node 9 are nodes 1, 2, and 5. So the common ancestors will be nodes 1 and 2. Cousins. Many of you might have guessed this also already. So nodes having the same grandparent are known as cousins. So nodes 6 and 7 have the same grandparent 1, so they are known as cousins. Properties of a tree. Tree can be called a recursive data structure. Recursion means solving a big problem by dividing it into sub-problems such that all of them can be solved in a similar manner. So here we have a tree in which the root node has been represented by 1, right? So if I remove this root node, then I'll be left with two subtrees having root nodes 2 and a root node 3, right? Similarly, if I remove the nodes 2 and 3 also, then I'll be left with subtrees having roots 4, 5, 6, 7, and 8. So the tree data structure itself consists of several subtrees. This property of trees is quite useful in implementing operations like insertion, deletion, and search in trees. Depth and height of a node. Depth of a node X is the number of links or edges in a path from root to that node X. So let us take an example. So let's say we have to find the depth of node 5. So we have to travel from the root node, which is 1, to node 5. So from 1, we'll go to node 2, and from node 2, we'll go to node 5. So the number of links through which we have to travel was 2. So the depth of node 5 is 2. Similarly, we can find the depth of node 10, let's say. So from 1, we'll move to 10. So from 1, first we'll go to 2, then from 2 to 5, and then from 5 to 10. So we have to travel through 3 links. So the depth of node 10 is 3. The nodes at the same depth are also at the same level. So the depth of the root node is 0. So it is at level 0. The nodes 2 and 3 have a depth of 1. So we can say they are at level 1. Similarly, nodes 4, 5, 6, 7, and 8 are at level 2. And nodes 9, 10, and 11 are at level 3. The height of a node X is the number of edges in the longest path from the node X to the leaf node. So let us understand this also with an example. So let's say we have to find the height of node 2. So there are so we can from node 2 we can travel to 4 leaf nodes, right? We can travel to node 4 to 9 to 10 and also to node 6. But we will select that node in which we will have to travel through the maximum number of these links. If we move from 2 to 4, then we will have to travel through one link. If we move from 2 to 9, then we will have to travel through two links, right? And if we travel from 2 to 10, then also two links. Similarly, from 2 to 6, we will have to travel through one link. So the maximum number of links through which we will have to travel is 2. So the height of node 2 is 2. So let's take another example, and we have to find the height of the root node, which is 1. So we'll take the longest path to any leaf node from the root node. So we could take any of the nodes 9, 10, and 11. All will yield the same answer. So let's say I take 9. So from 1 I'll go to 2, then from 2 to 5, and from 5 to 9. So I had to travel through 3 links. So the height of the root node is 3. The height of the tree is the same as the height of the root node. So the height of this tree is 3. The binary tree. The simplest tree is one in which each node can have at most 2 children. Such a tree is known as a binary tree. As you can see in this tree represented here, each node has either 0, 1, or 2 children. So such a tree is known as a binary tree. Now that we know the number of children, we can design the structure of a node for a binary tree. We know that we require one field to store the data, and now that we know that each node can have at most 2 children, we require 2 fields, one to store a link to each of the child. If any or both the children are absent, then what we can do is we can set their links to address 0 or null. So here we have the programmatic structure of a node. I have used C++ structure to implement it. So we have one field to store data, which is of integer type. We have 2 fields to store links to the left child and one to the right child, which are of data type pointers. Let us go over the types of binary trees. The first is strict or proper binary tree. In a strict or proper binary tree, a node either has 0 children or 2 children. As you can see in this binary tree, each and every node either has 0 or 2 children. So such a tree is known as a strict or proper binary tree. A complete binary tree is one in which all the levels are completely filled. The only exception can be that the last level is incompletely filled. And in that case, all the nodes in the last level must be as left as possible. Now let me tell you what I mean when I say completely filled nodes. So we have the root node at level 0, right? And we can only have the root node at level 0 because it is the first node. And then we have at level 1, we have both its children. So a level is completely filled if it has the maximum number of nodes that it can have. So at level 1, if both the children of the root node are present, then it will be completely filled. Similarly, if all their children are also present, then level 2 will also be completely filled. So here we have a complete binary tree in which level 0 is completely filled with the root node. Then we have both of its children. So level 1 is also completely filled. Then all of their children are also present. So level 2 is also completely filled. But level 3 is incompletely filled, right? Because the children of nodes 6 and 7 are absent. So in that case, all the nodes on the last level must be as left as possible, right? So as you can see here, all the nodes are as left as they can be. So if nodes 10 and 11 would have been the children of any of the nodes 6 or 7, this tree would not have been a complete binary tree. Perfect binary tree is one in which all the levels are completely filled. So at level 0, we can only have the root node, so it is filled. At level 1, as both of the children of root node are present, it is also completely filled. And as all the children of nodes at level 1 are also present, so level 2 is filled. Similarly, level 3 is also filled. So such a tree is known as a perfect binary tree. Now there are two ways to implement binary trees. First is using dynamically created nodes. In this method, we use the new operator or the malloc function to create nodes dynamically, and then we access them using pointers. The second method is the array implementation. This method can be used to implement only complete binary trees because the logic which we will use in this implementation is only applicable in case of complete binary trees and not any arbitrary tree. So here we have an array and a complete binary tree. This array can be used to this array can represent this complete binary tree if we follow the logic that for a node at index I, its left child will be present at index 2i plus 1 and its right child will be present at index 2i plus 2. So in a tree, the first node is the root node, right? So in its array implementation also, the first index is the root. So let's say we want to find its left child. So the left child will be present at index 2i plus 1, which will be 2 into 0 plus 1, which will be index 1. So we can also cross check it with the tree that the left child of the root node is 4. Similarly, if we want to find the right child, it will be 2i plus 2, which will be index 2. So 1 is the right child, and we can cross check it again. So in this way, complete binary trees can be implemented using arrays. A binary search tree is a binary tree in which for each node, the data of all the nodes in the left subtree is lesser than the data of the node, and the data of all the nodes in the right subtree is greater than the data of the node. So let's take an example to understand this better. So here we have two binary trees, binary tree 1 and binary tree 2. And we have to tell whether they are binary search trees or not. So let's take binary tree 1 first. So let's check the condition for the root node. So the data in the root node is 15. So left of root node we have 10, 8, and 12, which are less than 15, right? And right of the root node we have 20, 17, and 25. All of them are greater. So for the root node, the condition satisfies. Then we have next let's check the condition for node 10. So in the left subtree of 10 we have 8, which is less, and in the right subtree we have 12, which is greater. So for 10 also the condition satisfies. For 8 and 10 for 8 and 12, as they don't have any children, we don't have to check for them. Next, let's check for 20. So left of 20 is 17, which is lesser, and right of 20 is 25, which is greater. So for 20 also the condition satisfies. So the binary tree 1 is a binary search tree as all the nodes satisfy the condition. So here is another exercise for you guys. You have to tell whether binary tree 2 is a binary search tree or not. So you have 5 seconds. You can type your answers in the chat box. So now let us go over it. So let's check the condition for node 15 first, or the root node 15 first. So let's go over its right subtree first. So we have 20, 17, and 25, all of which are greater than the root node. In its left, we have 10 and 8, which are less. And then 16, which is greater than 15. So for the root node, the condition doesn't satisfy. Hence, this tree is not a binary search tree. Search operation in binary search tree. The search operation is in binary search tree is quite time efficient. Let us take an example to understand the algorithm. So here we have a binary search tree, and let's say we have to search for node having data 4. So we'll start at the root, we'll compare 4 with 8. So 4 is less than 8, and we know that in a binary search tree, all the nodes in the left subtree are lesser. So if 4 is present in this binary search tree, then 4 must be left of it. So we move left, then we compare 4 with 3. So 4 is greater than 3. And using the property of binary search tree, we know that the nodes in the right will be greater. So we move right. Then we compare 4 with 6. So 4 is less than 6. So we must move left. So we move left. And then a match is found. So we return true. Similarly, we can search for any other node also. So let's say we want to search for node 13. So we compare 13 with 8. So 13 is greater than 8. So we know that we must move right. So then we compare 13 with 10 again. So it is greater. So we know that we must move right again. So we then compare 13 with 14. So we must move left now because it is lesser. And then we find the node and a match is found. So we return true. Finding the minimum and maximum elements in a binary search tree. So we know that in a search tree states that for any node, all the nodes in its left will be lesser and all the nodes in its right will be greater. So it is only logical that we should move as left as we can to find the minimum element in the binary search tree. So let's take an example. We have a binary search tree here. Let's say we have to find the minimum element in this binary search tree. So we'll start at the root and we'll move as left. So this root can also be the minimum element if it doesn't have a left subtree, because all the elements in its right will be greater than 15, right? But it has a left subtree, so we move left. Similarly, 10 can also be the minimum element, but in case it doesn't have a left subtree, but it does, so we move left again. So 8 doesn't have a left subtree, so we cannot move left any further. So 8 is the minimum element in this binary search tree. Similarly, if we want to find the maximum element, we'll move as right as we can. So we'll start at the root, and this root can also be the maximum element if it doesn't have a right subtree, but it does, so we move right again. Similarly, 20 also have a right subtree, so we move right again. So 25 doesn't have a right subtree, so 25 is the maximum element of this tree. Tree traversal. It refers to visiting all the nodes in the tree exactly once in a particular order. Visiting technically means reading or processing the data in a node, but for us, it will simply mean printing the data in the node. So the tree traversal method, which we will discuss, is known as pre-order traversal. In pre-order traversal, for every node, we will first visit the node. Visiting is simply printing the data in the node. Then we'll visit its left subtree, and then we'll visit its right subtree. So if I use the notation as D to represent visiting or printing the data in the node, L as visiting the left subtree, R as visiting the right subtree, then in pre-order traversal, we have to apply DLR on each and every node in the tree. So let's understand it better by applying it on this binary tree. So we'll start at the root, and first we have to print the data in the node because we are applying pre-order traversal. So we'll print F. Then the next step is L, right? We have to move to the left. So we move left. Then we reach the node D. So we again apply DLR on it. So we print the node D. Then we again move left and to reach the node B. Then we print B and we again move left to reach the node A. Then we print A. So A is a leaf node, so it doesn't have a left subtree nor a right subtree. So what we can consider is that we have completely visited its left subtree. So the D part is done for A, the L part is also done for A, and as it doesn't have a right subtree, the R part is also done for A. So we move back to B. So for B also, we have done the D part. We have completely visited its left subtree also. So now we move to its right subtree. So we go to C. So we print C. So C is also a leaf node. So the D, L, and R part are also done for it. So we move back to D. So for D, we are finished with the printing of the node and visiting the left subtree. So we move right of it to complete the R part. Then we print E. So it is also a leaf node. It doesn't have any of left subtree and right subtree. So the L and R part are also done. So we move back to F. So for F, we have printed the node and we have completely visited its left subtree, right? So now we move right. So for J, we print the node first to complete the D part. So we print J, then we move left. So for G doesn't have a left subtree. So we are so first we print G and then we move to its left subtree, but it doesn't. So we can consider it all visited. So the L part is also done, and then we move to the R right of G, and then we print I. Then we move left of I to print J, then H. Then H is also a leaf node, so the left subtree and right subtree are done. We can consider it done. So then we move back to I. So we are done with D and L for I. So and it doesn't have a right subtree, so we can consider R also done. So we move back to J. So for J, we are done with the data part and the left visiting the left subtree part. So we move to K. So we print K. Then it is also a leaf node, so the L and R part can be considered visited. So in this way, we have completely traversed the entire tree in a pre-order fashion. So that will be all for the tree data structure. Now, Japnur will be taking up the topic of recursion.
Yeah, thank you, Siddhant. Just give me a second. So, hello everyone. My name is Japnoor Singh. I am a second year ECE student, and I've also been a part of IEEE for more than a year now. Before we begin anything, I just want to remind you that please fill the attendance form. You will be getting the participation certificates based on that. And also stick to the end because we have a Kahoot show, a Kahoot quiz ready for you guys. Now, yeah, sorry for that. I hope my screen is visible. And so we'll be moving on to the algorithms part now. And the topic we are going to cover today is recursion. Recursion is one of the most important topics in programming. It is not only used for questions related to recursion, but also in various other data structures. So one of the main questions right now is what is recursion? Recursion is nothing but a process in which a function calls itself directly or indirectly. Um, as you can see here, we have a function recurse, and I'm calling the function recurse inside the function itself. This whole part is known as recursion, and when we call the function in itself, that call is known as the recursive call. So basically, in simple terms, we can say that when we solve a problem via the solution of the smaller problem of itself is known as recursion. Or basically, we are defining a problem in itself. Now, I'll give you a very real life example of recursion. A Russian doll is probably one of the best examples. Uh, it is basically a doll that has a smaller doll inside of it, which in turn has a smaller doll inside of it, which is very similar but smaller in size. And it goes on until the doll is too small to contain another. Uh, Again, a real life example. But now let's move on to a more practical example for a recursion. So let's just say I want to calculate 2 to the power 4. We all know that I can write down 2 to the power 4 as 2 into 2 to the power 3. Also, I can break down 2 to the power 3 as 2 into 2 to the power 2. 2 to the power 2 again can be broken down as 2 into 2 to the power 1. 2 to the power 1 can again be broken down as 2 into 2 to the power 0. And 2 to the power 0, I can also write it as 2 into 2 to the power minus 1. I can just go on until 2 into 2 to the power minus 2, minus 3, minus 4, and so on. But I have to stop somewhere. Okay, हम मतलब I just can't go continuously because it will go until infinity, and I will have a loop, basically an infinite loop. और अगर एक इनफाइनाइट लूप हम चलाएंगे तो बेसिकली तुम्हारी मेमोरी फुल हो जाएगी, तुम्हारा सिस्टम क्रैश कर जाएगा। टेक्निकल वर्ड फॉर दिस स्टैक ओवरफ्लो। उसके बाद जाके लूप रुकेगा। ऑब्वियसली वी डोंट वांट दैट, इसलिए व्हाट वी डू इज वी डिफाइन अ बेस केस। नाउ बेस केस इज अ पॉइंट इन द फंक्शन वेयर वी स्टॉप द फंक्शन, जहाँ पे मैं, एंड वी ऑल नो दैट एनीथिंग टू द पावर 0 is 1. So when I reach this point, that 2 into 2 to the power 0, I know that 2 to the power 0 is 1. So 2 multiplied by 1 is 2. And so this is where I define the base case. And once I get the value of this part, I can easily calculate all the values of this part, of all the other parts, basically that came before it. Now, let's एक और एग्जांपल ले लेते हैं, तुम्हें भी थोड़ा ज़्यादा क्लियर हो जाएगा. So let's say I want to calculate 5 factorial. I'm sure you all have studied what factorial is. So I can write down 5 factorial as 5 into 4 into 3 into 2 into 1. Uh, Again, very simple problem. But I can also write down 4 into 3 into 2 into 1, basically the green highlighted part, as 4 factorial. So 5 multiplied by 4 factorial, I can break down 5 factorial as 5 multiplied by 4 factorial. Similarly, I can write down 4 factorial as 4 multiplied by 3 factorial. 3 factorial can be written down as 3 multiplied by 2 factorial. And 2 factorial can be written down as 2 multiplied by 1 factorial. And as we all have studied before, 1 factorial is 1. And hence, this will be a base condition for this problem. Now I'm focusing very much on this base condition. I will be giving you a coded example for why do we use base condition and why is it compulsory. So just wait a couple of minutes. Now, so just one very simple example of recursion. So what I want is I want to print out the number which I give. So basically, if I give out the input as 3, I want to print out 3 to 1. So basically, I want to print out numbers in descending order. So first step would be to write down the base case. That will be if n is equal to 0, just return. We don't want to write 0, and hence we're not including 0 in a function basically, and we're making it as the base case. Then I make the recursive call that once I've printed n, print n minus 1. This recursive call is how recursion works. And then I write down C out of n, that is print out the number I have put in. And this basically the function that you write, or the code that you write between the base condition and the recursive call, is known as the work or the function. So I'll just give you a small example. For example, I input 3. So it will first check that 3 is not equal to 0. It will check, so it won't return. It will move on to the next step, that is C out of n. So I'll print out 3, and then we'll move on to the recursive call, that is print 3 minus 1, that print of 2. Again, we are calling print of 2, so we put in 2 over here. 2 is not equal to 0, we print out 2. Then we move on to the recursive call, 2 minus 1, that's 1. 1, again, we call this function. 1 is not equal to 0, hence we print out 1. Now we go to print of 1 minus 1, that is 0. And again, when we put 0 over here in this n, it will just go like, if it will first compare with the base case. Obviously n is 0 this time, so here we'll return the function, that is we'll stop over here and we'll go back to the main function, and hence our output will be 3, 2 and 1. So that is how basically what recursion is and how it works. Now again, now this program, I'll just give you a very small example of why base case is necessary. So we'll start with a very simple program, that is printing out hello world. You all know this obviously. So we are just printing out hello world over here, see out hello world. Now I can also write this program using function. So I define a function hello. I'm calling the function hello in the main function, and in the function hello, I'm calling out see out hello world, that is print out hello world. You run the function, you run the program. The output would be hello world. Now, what we have studied till now, that whenever a function call itself, it's known as recursion, and that call is the recursive call. So what do I do here is I do exactly that. I call the function hello inside itself. So once you run this function, what will happen is you will get an infinite loop of hello world. It will keep on going until your memory is full and the system crashes again. So what I do here is that I'll bind the number of times we print hello world. So it should technically solve my problem. But so what I do here is we print hello n minus one times. We give a parameter n. For example, let's say I want to print five times. So I will say just print. I'll give int n as five, and I will print four more times. So once and then four more times. But once you run this function, you will again notice that it goes on until infinity. But we have the same problem, but why? So what we'll do is we'll try to debug it. So what I'm doing here is I am printing out n along with the cout hello world so that we know at what number we are. So for example, if I put n as 10 and we run the function, we'll get hello world 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. This is what we expected till 1 is what we should have gotten in the first place. But as you will notice that it goes on until 0, minus 1, minus 2, minus 3, and it will go on until minus infinity. Of course, we don't want that. So what do we do here is we write down the base case. Now I'll just say that if n is equal to 0, if n matches 0, then you just stop the function right over there and we go back to the main function. So what happens here is I print out hello world 10. It will first check, it will put in 10. It will check 10 is not equal to 0, and it will see out hello world along with 10, and then we go to hello world 9. Similarly, it will go on until hello world 1. Once we reach hello world 1, it will see it's not equal to 0. So it will print out hello world 1, and then it will call the function for hello 1 minus 1, that is hello 0. So what happens here is we'll put int n as 0. It will check n is equal to 0, and then so this so basically we'll return the function over here once base case is achieved. So we'll return back to the main function and the function will stop here. So why I gave you this example is to show you that base case is compulsory for stopping the recursion. So any question of recursion you do, base case will always be necessary. Otherwise, it will be again your system will crash because the memory will get full, and that's known as stack overflow. Now we'll do a couple of questions now. Uh, and hopefully by the end of these questions, you will have a very clear idea of what recursion is and how it can be implemented. So the first question is that we have to print down five numbers in descending order. We have done this before, so I'll just give you a quick review of how to do it. So first we look at the recursive tree. Recursive tree is basically the logic by which you will solve the problem. Once you understand the recursive tree, solving a problem becomes very easy. So let's say I want to print five numbers, so 5, 4, 3, 2, and 1. So I pass for, let's say, a function. I pass in 5 in that. I print out 5. It will go to 4. I print out 4. It will go to 3. I print out 3. It will go to 2. I print out 2. Then again it goes to 1. I print out 1. Once it reaches 0, that's the base case. We don't want 0 in our question. So here we'll return the function. Now let's code it. Again, a very simple code. We first define the base case. If n is less than or equal to 0, you just return the function, you stop the function over there. We print out n, and then we make the recursive call to count of n minus 1. And you just take the input from the user in descending order, and you call the function over here. Again, I don't think I need to explain it. So you just pass in 5, it will print out 5, go to count of 4, then 4, 3, 2, 1, and then for 1, it will become 0 over here. It was equal to 0, and hence it will return the function, and the function will stop. And we get a desired output. Now let's move on to the next question. Again, it's also very much similar to the first question, but again, very different in its own way. So we are going to print five numbers in ascending order. We just did descending order, and now we're going to do ascending order. Again, let's take a look at the recursive tree. So I define a function, I put in the value 5, it goes to 4, it goes to 3, it goes to 2, it goes to 1, it goes to 0, again the base case. From 0 to 1, we don't return anything. From 1 to 2, when it returns from 1 to 2, we print out 1. When it returns from 2 to 3, we print out 2. When it returns from 3 to 4, we print out 3. When it returns from 4 to 5, we print out 4. And when it returns from 5 to the main function, that is when our recursive function ends, we print out 5. Now let's take a look at the code. So again, I have defined the function count. The parameter is integer n. We take int n from the user, ascending order, and we call out the function. So again, first I'm calling out the base case. I'm listing on the base case that if n is less than equal to 0, you return, stop the function. Then we are first getting, we are first making the recursive call, that is count of n minus 1, as we saw here. We are first making the call and then we are printing it later. So what happens is we first make the recursive call and then we print out our integer n. So for example, I pass out 5, it will first go to 5. 5 is not equal to 0. Count of 5 minus 1, that is count of 4. It will go here. It will call the function before reaching the step. So again, it will happen with 3, 2, 1. Once it reaches 0, it is it. So we did basically return the function, and then we print out all these values with steps we did before. Again, recursive tree again is a very important concept. Once you know how to make the recursive tree and you understand how the recursive tree works, the writing the program is basically a very simple task for you then. Now, the third question, and it's one of the most interesting questions I would say for recursion, and I'm sure you all have done this before. That is to find the factorial of a number. We all have studied this in our schools. So I can write down n factorial as n multiplied by n minus 1 multiplied by n minus 1, so on until 1. So basically, if I want to find out 5 factorial, it will be 5 into 4 into 3 into 2 into 1, that is 120. So basically, I can just define factorial of a number as factorial of n is n multiplied by factorial of n minus 1. This is the formula of finding a factorial of a number n, and this is the statement that we are going to use now. So this question can be solved in two ways. First is the iterative way, that is using the loops. Again, a very simple program, you all must know this. And the second part is the recursive program. So basically we can write it in two ways, and we're going to discuss both. So first we'll see the iterative part, the iterative solution. So what I'm doing here is I have taken basically defined 3 integers. One is n, that is the number we want the factorial of, and the user will be inputting that number. We have taken an integer fact, we are initializing it by 1, and we have taken an integer I for the loop. So we run a loop from 1 to n, and I plus plus the each step, and we are just multiplying the fact which we started from 1 with the current number we are on in the loop. And once you print out the fact or the integer fact, you'll get the number you want. For as you can see, 6 factorial is 720. Again, a very simple solution, but we had to discuss it. Now we have a look at the recursive tree. So let's say I want to find 5 factorial. I can write down 5 factorial as 5 multiplied by 4 factorial. 4 factorial can be written down as 4 multiplied by 3 factorial. 3 can be broken down as 3 multiplied by 2 factorial. 2 factorial can be broken down as 2 multiplied by 1 factorial, and 1 factorial, as we know, is 1. And then this will be a base case. So what happens is you reach this part and then we start returning the function. So once we go from here, we get the value 1. 1 factorial is 1. So 2 multiplied by 1, 2. For this step, the value is 2. We return 2 in 2 factorial. So 3 multiplied by 2 is 6. That is 3 factorial over here. So we put in the value and you go there, and finally it will be 5 multiplied by 4 factorial. 4 factorial is 24. So 5 into 24 is 120. And once we reach the final step, we get the final value, that is 120. Now let's take a look at the solution. So what I have done here is first I've defined an integer n. Take the input from the user for the number you want to find the basically factorial for, and you see out the factorial of n, and you call the function factorial n, and factorial n takes a parameter that is integer n, and in that I first defined a base case. If n is less than or equal to 1, you return 1, because we know that factorial of 0 and factorial of 1 are both the same, that is 1. Else, what we do here is we return n multiplied by factorial of n minus 1. Again, this is the formula we just did. Factorial of n is n multiplied by factorial of n minus 1. And this is what we write down here. And we are making the recursive call over here. When you run this function, you put in the value 6. Again, I just don't want to bore you guys. So again, you can just make a dry run in your mind that you put down the value 6, you'll get 720. Now we'll move on to the last question for recursion for today, and again a very important problem, Fibonacci series. Uh, and I hope that you all have studied Fibonacci series in school. Well, you all might have, but I'll just give you a quick definition. So as you can see the highlighted part, term n, so basically any term in a Fibonacci series can be defined as sum of its previous two terms. So for example, if I want to define the fourth term, I can define it as the sum of third term and the second term. The third term would be 2 and the second term would be 1. So sum of that is 3. That's the fourth term. So I have written the series over here, that is 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. And at what position they are, or at what's their index. Now, from this little portion, it must be very clear to you what our base case would be, or should I say cases? Because in this case, the first two cases, the first two parts will always remain the same. The first two indexes will always be the same. That is 0 and 1, and hence that would be a base case. I'll show you the recursive tree, so it would be a little more easy for you to understand what I'm talking about. Again, this question can be solved using two ways, that is the recursion and loops. So first we'll take a look at the iterative solution using loops. So what I've done here is I have taken an integer n, integer first, second, and next. First I've initialized by 0, second I've initialized by 1. So we know that the first index of Fibonacci series is 0 and the number at the second index is 1. So that's why. And we have taken the number next. We take a input from the user. We run the loop from 0 to n. And so we basically see out first. That would give us our Fibonacci sequence. And we then make the next function equal to the first plus second integer. The first would become second, and the second would go to next. Again, a very simple solution. And once you run it, for example, you want to find the Fibonacci of 7, that would be 0, 1, 1, 2, 3, 5, and 8. Now let's have a look at the recursive tree. A very simple recursive tree. For example, I want to find out Fibonacci of 6. It would be the sum of Fibonacci of 5 and Fibonacci of 4. Fibonacci of 5 can be written down as Fibonacci of 4 and Fibonacci of 3. 4 can be written down as 3 and 2. 3 can be written down as 2 and 1. And 2 can be written down as 1 and 0. Again, it is 1. 4 can be written down as again 2. So 2 can be written down as 1 and 0. We come here. 4 can be written down as 3 and 2. 3 can be written down as 2 and 1. 2 can be written down as 1 and 0. That is 1 and 0. We have both the cases. 3 can be written down as 2 and 1. 2 can be written down as 1 and 0. So as you can see, we have defined a base case before, as I told you. So Fibonacci of 1 is 1. Fibonacci of 0 is 0. That is, these two will be a base cases for this question. Now we have a look at the code. So what I've done here is I have taken an integer, defined an integer n. We take the input from the user and we see out Fibonacci of fib of n. So I've defined a function fib of n here, which takes the parameter integer n. And first we'll again write down the base case, that if n is equal to 0 or n is equal to 1, you return n, because we know that Fibonacci of 0 is 0, Fibonacci of 1 is 1. And then what do we do is we make the recursive call, that is return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Again, I'll just take you back. Term n can be written down as sum of term Fibonacci of n can be written down as Fibonacci of n minus 1 plus Fibonacci of n minus 2. That's exactly what we do right here. And once you run the function, again you write down 8 and then it will give you the answer 21, because 8 would be 21, as you can see over here in the highlighted part. So that's all from my side. That's I hope that you have understood what recursion is and how is it implemented. Again, we have covered very basics of recursion in this part, and of course, the uses of recursion are endless. And that's all from my side. Thank you very much. Now I will ask Akshat to take from here.
So, is my screen visible, Japnur?
Not right now, Akshat.
Now,
Yeah, yeah, yeah.
so hi, my name is Akshit. I am from second year COE branch, and I have also been in IEEE for 1 year, like Japnur and others that have come before me. So, I will continue from here. So, let us again analyze the recursive tree of Fibonacci of 6 and try to make a few key observations. To calculate Fibonacci of 6, we have to calculate Fibonacci of 4 and Fibonacci of 5. To find Fibonacci of 5, we have to find Fibonacci of 3 and Fibonacci of 4. To find Fibonacci of 4, we have to go to Fibonacci of 2 and Fibonacci of 3. And for Fibonacci of 3, we have to find Fibonacci of 1 and Fibonacci of 2. For Fibonacci of 2, we have to find Fibonacci of 0 and Fibonacci of 1, which are our base cases. So we return the value from here, which is then added with Fibonacci of 1 to give the value Fibonacci of 3, which is returned to Fibonacci of 4. Now, in the second branch for Fibonacci of 4, we have to find Fibonacci of 2. But we had already calculated Fibonacci of 2 while calculating Fibonacci of 3. So again, going in the branches for Fibonacci of 0 and Fibonacci of 1 would be extra work. Similarly here, we have to calculate Fibonacci of 3 again for calculating Fibonacci of 5. But we had calculated Fibonacci of 3 while calculating Fibonacci of 4. So going in the recursive tree for Fibonacci of 3 would again be repeated work. And similar is the case with Fibonacci of 4. So it is clearly visible from this recursive tree that all the places that where we have crossed out with a red cross are repeated work and can be avoided. So since we know programming is all about optimization, we must find a way to somehow reduce the time, as doing the code this way would make our code very slow, and that is not very desirable. So how do you guys think we can achieve this? So one simple trick that we can apply is when we calculate value for any Fibonacci term, we just store it in an array, and when we encounter that term once again in another tree, we just return that term if it has been calculated already. So to the right, we have a recursive tree which will be formed after we have performed this optimization. And it is clearly visible that it is very neat and clean, as we do not go into the recursive tree for Fibonacci of 3, 4, and 2 a second time, as we had already calculated them before. So what I'm telling you, I would like to show you in a code. So this is the code. I declare an array named dp and I initialize all its value with -1, since we know that none of the Fibonacci terms have -1 as their value. So this will act as a check. So now we call on the function and we pass the array to it so that we can check. So first and foremost, most importantly, in any recursive question, we have to write the base case, or else we will encounter an infinite loop and the code will run out of memory. Then we check if dp of that term is -1. If that term is not equal to -1, that is we had already stored some value in it and we return that value. But if it is -1, then that means we are encountering that term for the first time and we have to do the desired operations on it. So we call on the recursive tree for Fibonacci of x-1 and Fibonacci of x-2, as Japnur showed in his slide, that is the recurrence relation, and store it in an answer. So here comes the important step where we store the answer in our array, so that the next time we encounter that term once again, we can check if it is not equal to -1, then we will return that term value. So we store it in an array and then we return that answer. So this is the way to so that we can implement this very simple optimization. Fibonacci of 7, as we can see, is 13. So congratulations guys, you just understood one of the most important algorithms in programming, that is dynamic programming. So we can sum up dynamic programming with a simple quote, that is, those who cannot remember their past are condemned to repeat it. So where do we use dynamic programming? Two conditions must be met for us to use dynamic programming. First one being optimal substructure. That is, we can break down a bigger problem into its smaller subproblems, as we have seen in the previous recursive questions. That is Fibonacci question. Fibonacci of x is equal to Fibonacci of x minus 1 plus Fibonacci of x minus 2. And second is overlapping subproblems, because that is the only case when DB would be helpful, because will be doing repeated work due to overlapping subproblems. So in that case, we can apply this optimization. So to make the concept more clear, I would like to explain another question. So the question name is minimum steps to one problem. The problem statement reads, given a positive integer n, we can perform three operations on it. That is, we can decrease n by 1. Second operation, if n is even, we can divide it by 2. If n is a multiple of 3, then we can divide it by 3. And we have to find the minimum number of operations that would be needed to reduce to n. So let us assume that n is a number that is a multiple of 3, a multiple of 2, and if it is a multiple of 3 and 2, then obviously it would be greater than 1. So let us assume that it takes z number of steps to reach n by 3 from 1, y number of steps to reach n by 2 from 1, and x number of steps to reach n minus 1 from 1. So to reach n from n by 3 or n by 2 or n minus 1, it would take one step each. So the minimum path to reach n would be the minimum path out of n by 3, n by 2 or n minus 1. That is, if we reach n minus 3 in least number of steps, then to reach n we have to come through n by 3 and not via n by 2 or n minus 1. So the recurrence relation can be written as, f of n would be minimum of x, y and z plus 1. That is minimum of number of steps to reach n minus 1, minimum of number of steps to reach n minus n by 2, and number of steps to reach n by 3, and we add 1 to take 1 steps to reach n. So it would be more clear with this recursion tree. So let us draw a recursion tree for n equals to 10. So 10 is a multiple of 2 and 10 is greater than 1. So first let's go to 5. 10 divided by 2. 5 is neither a multiple of 3 nor a multiple of 2. So only cases of 4. 4 is a multiple of 2. So we go to 2. And 2 is a multiple of 2 as well as greater than 1. So we go to 1. And 1 is our base case. That is, it takes no step to go from 1 to 1. So we will return 0 from here. So for 2, the answer would be minimum of 0, 0 plus 1. There are only two cases, that is only x and y, because 2 is not a multiple of 3, so that would not be considered here. So we return 1 from this branch. In the other branch, we go to 3 from 4. 3 is a multiple of 3, so we go to 1, divide 3 by 3, which returns 0, and 3 is greater than 1, so we decrease 3 by 1, so we get 2. And here dp comes into play. We had already calculated the answer for 2 here, and we returned it 1. So we also store it in our dp array, and we return the answer 1 and do not go further in the recursion tree. So the answer for 3 would be minimum of 0, 1, which would be 1, which would be 0, and we add 1 to reach 1 step to reach 3 from 1 to 3, and we return 1 to 4. For 4, we do minimum of 1, 1 plus 1, that is 2 steps to reach 4 from 1. And from 5, we return minimum of 2, that is 2 only. So we return 2 plus 1, that is 3 steps to reach 5 from 1. And now we go into the second branch, that is for 9. Now 9 is a multiple of 3, so we divide 9 by 3, that is 3. And the answer for 3 had been calculated already here, and we stored it in our dp array, that is answer is 1. So we return it here. And we go into other branch, that is for 8. 9 minus 1, 8. 8 is a multiple of 2. So we go to 4, and the answer for 4 was calculated already. So we return answer that we had already calculated, that is 2. And we go to the second branch, that is 8 minus 1, 7. Now 7 is neither a multiple of 3 nor 2. So only case left is 6. Now here 6 is a multiple of 3, 2 as well as it is greater than 1. So 6 divided by 3 is 2, and answer for 2 was calculated already. So we return 1 here. 6 divided by 2 was 3. Answer calculated already here. So we return 1. And 6 minus 1 is 5. The answer for which we had calculated in the other recursion branch. So we return 3 from here. So the answer would be minimum of 1, comma 1, comma 3, that is 1 plus 1. So 2 steps to reach 6 via 1. So we return 2 from here. To reach 7 via 1, we need do minimum of 2 plus 1, that is 3 steps. To reach 1 by 8 via 1 from 1. So we do minimum of 2 comma 3, that is 2. 2 plus 1, 3 steps. For 9, we do minimum of 1 comma 3, that is 1 plus 1. 2 steps to reach 10 by 9. So we do minimum of 2 comma 3, that is 2, and add 1. So 3 steps are to be taken to reach 10 from 1. So most of you must be thinking in when I told this problem in the starting that we should divide a number by 3 if it is divisible by 3, or if it is a multiple of 2 we should divide by 2. But that is not, but doing that will not give us the right answer, as it is clearly visible. 10 is a multiple of 2, but our correct answer does not come through 5, but it comes through 9. So that is why DP is applicable here, because there are overlapping subproblems, optimal substructure, as well as we have to check for all possible cases. So let us see the code for this particular problem. So here we declare an integer n and then enter the number n. So the number for which we have to check, find the minimum number of steps. Here I have declared the DP array globally, so that I do not have to pass it in the function again and again, and that would reduce our work. So I initialize all its values to -1, because it does not take negative steps to reach any number from 1, and we call on the function. So first of all, most important thing, base case, if x is 1, so we return 0, that is it does not take any number of steps to reach 1 from 1. So now we do the lookup case, that is we check if the value is calculated already. If dp of x does not store -1, then that means the value had been calculated already and stored in the dp array. So we return that value. But if it is -1, then that means we are encountering that particular number for the first time, and we go into the working of the recursion, working of the algorithm. So I have created 3 variables, option 1, 2, and 3. It initialize them with int underscore max. So int underscore max is the maximum possible value that an integer can hold, and we can use this keyword using by including the header file climits. So if x is a multiple of 3, that is x mod 3 is 0. So we store our answer in option 3. We store our answer for x by 3, and we add 1, that is one step to be taken from x by 3 to reach x by multiplying it by 3. And so if x is a multiple of 2, we store it in option 2. And if x is not equal to 1, that x would obviously be greater than 1, so option would be done. So there is no need to put a condition on option 1, and we do option 1 equals to minimum steps of x minus 1 and add 1 to reach x from x minus 1. So now we can see why I have declared the option 1, 2, and 3 with int max. Let us assume that x is not a multiple of 3. So this we will not go in this if block, and option 3 would remain int max. So when I will be taking minimum of option 3 with any number, we will get that number only. Like we can see minimum of n comma infinity is n only. So like that we will get the answer to be correct one, and then we store that answer in a DP array and return that answer finally. So this was all about dynamic programming. With this, we would like to end I would like to end my presentation. And those who have not filled the form, could you please fill that NS form so that you could get the certificate. So Ansh would carry on from here.
All right. So कैसा लगा सबको session? Have you all learned something or at least enjoyed? एक बार chat box में बताओ, क्योंकि the boring part is finally over. The boring part is finally over. No more learning, no more cramming, no more दिमाग में परेशानी. Now we'll have fun. All right. So अब time आ गया है. Yes, it was not boring. I know. मेरे को भी पसंद है, but ठीक है. Yeah, great presentation, everyone. Yeah, Ankush, Akshay, Japnoor, Siddhant, great work. So now we'll be starting with Kahoot quiz. Actually, we'll be going on with it, and you all will be eligible for prizes. काफी सारे prizes और giveaways हैं IEEE के पास. So हम Kahoot quiz organize कर रहे हैं हर Tech Week के event में. So be ready. अगर किसी को और भी join करना है अभी आ जाए. I'll be sharing my screen and the Kahoot code will be visible on that. All right, so let's go. मैं इसका लिंक भी आप लोगों के साथ शेयर कर दे रहा हूँ. आई एम शेयरिंग द लिंक. द गेम पिन इज 1905056. The game link is there in the chat box. So basically Kahoot is a 4-option MCQ type of quiz. There are other patterns as well, but we mostly structured the questions in true, false and into 4 options only. So एक छोटा सा क्विज है. सारे दोस्तों को बुला लो जल्दी जल्दी, क्योंकि अगर शायद ये अटेंड नहीं किया हो मगर कुछ आता हो आंसर तो स्टिल दे कैन विन द प्राइजेस. ऑलराइट, सब ज्वाइन कर लो जल्दी जल्दी से. प्राइजेस हैं, स्वैग्स भी हैं, कुछ क्रेडिट्स, वाउचर्स, सब कुछ है. सो जल्दी जल्दी ज्वाइन करो सब. लिंक मैं एक बार और शेयर कर दे रहा हूँ. दिस इज द Kahoot गेम पिन. मतलब लिंक है ये और पिन स्क्रीन पर है. इवन इफ वी स्टार्टेड उसके बाद भी यू कैन ज्वाइन. मतलब on the bottom corner the game pin will be visible. So ask your friends to join the meet at least so that they can be in loop with us throughout the quiz. सबको डायनामिक प्रोग्रामिंग समझ में आ गया? चैट बॉक्स में लिखकर बताना जरा, थोड़ा बहुत भी कुछ. नाइस. इट इज वन ऑफ द मोस्ट कॉम्प्लिकेटेड एल्गोरिथम पैराडाइम्स, तो काफी दिक्कत होती है. अरे बिल्कुल, नेकी और पूछ पूछ. हाँ हाँ, अरे बहुत करना पड़ेगा अभी. It is a little confusing, sure. Actually, there are multiple ways to implement it. मतलब not just in recursive procedure. कभी कभार iterative में भी करते हैं. तो काफी कुछ है अभी यार. एक घंटे में dynamic programming won't be over. It takes like weeks of practice at least to get fluent. तो अभी चिल करो. अगर इतना समझ आ रहा है जितना आज हुआ है कि फिबोनाची में कैसे लग रहा है या फैक्टोरियल में कैसे लगा सकते हैं, then it's great. मतलब you are doing well. Just assure yourself of that. ठीक है, बाकी सब समझ में आया ना? बाकी सबको भी बुलाओ यार. 18 बच्चे थोड़े खेलेंगे. अपने क्लास वालों को भी बोलो कि आ जाएं सब. We'll be starting in like 2-3 minutes. प्राइजेस क्या हैं? अरे यार 20 रुपए दोगे तो एक राज की बात बताऊंगा. है यार, प्राइजेस हैं, स्वैग्स हैं, कुछ गिव अवेज हैं हमारे पास. अदर देन दिस वी हैव क्रेडिट्स फ्रॉम माइक्रोसॉफ्ट एज्योर. इसके अलावा हमारे पास और भी चीजें हैं, लाइक वाउचर्स वगैरह भी हैं, काफी सारे कोर्सेज वगैरह के, कुछ प्लेटफॉर्म के सब्सक्रिप्शंस हैं. सो मतलब इट्स अ मिक्स एंड मैच लॉट. तो लेट्स सी. अरे तुमने पैसे दे भी दिए. शाउट आउट टू ध्रुव बख्शी भाई, सुपर चैट दे रहा है लड़का. नाइस. अरे भैया, अरे बाकी सबको बुलाओ यार, सबको बुलाओ. स्टार्ट करेंगे. कोई दिक्कत नहीं यार. आ जाओ सब आ जाओ जल्दी. We'll be beginning with the quiz. I'm sharing the game pin again in case someone has not joined. कोई पहले भी मीट में था, चला गया हो, शायद बोर होकर, पता नहीं है, उसे लगा हो कि करा हुआ टॉपिक है, तो आ जाओ वापस। बड़े से आसान से सवाल कर लो और प्राइजेस मिलेंगे। अटेंडेंस लिंक चाहिए, रुको। So attendance link is there in the chat box भाई। attendance सबसे important है। I think सब फर्स्ट ईयर्स को अब पता चल गया होगा कि क्लास से ज्यादा important अटेंडेंस है। तो बोलना मत कि अंश सर आए थे वो बच्चों को बिगाड़ने लग गए। हाँ, sure. We'll start the Kahoot quiz at 7:40. Okay, 3 मिनट है, बुला लो जिसको बुलाना है। हाँ, मेरा काम है बच्चों को बिगाड़ना। लाइक IEEE में भी मैं सबसे अच्छे मीम्स बनाता हूँ। सो गीतांश क्लास जाए बट अटेंडेंस ना जाए फॉर रीजंस। अरे बिल्कुल यार, क्लास जाए अटेंडेंस ना जाए। जब से DTU ID से एक्सेस ऑन कर रखा है ना टीचर्स ने, मैं वही करता हूँ, अटेंडेंस के टाइम ही ज्वाइन करता हूँ, मस्त, फिर निकल जाता हूँ। हाँ, पार्टी लेने के SIG मैं ही लेता हूँ सर। ये सब बातें नहीं बतानी होती ना, बच्चे मेरे पीछे पड़ जाए कल को कि पार्टी देने की SIG चालू करनी पड़ेगी। तो 31 people have joined। और किसी और को भी आना है, अभी तक SIG ज्वाइन नहीं की थी, स्टिल दे कैन ज्वाइन। टॉपिक क्या है? टॉपिक डेटा स्ट्रक्चर्स एल्गोरिथम है। एंड स्पेसिफिकली अगर प्रेजेंटेशन देखिए ना, तो उसमें जो भी अभी हम लोग क्वेश्चन देंगे वो कवर हुए होंगे। मतलब इन जनरल भी तुम्हें आ सकते हैं, ऐसी बात नहीं है कि अगर प्रेजेंटेशन नहीं देखी तो कैसे करेंगे जी। तो ऐसी कोई दिक्कत नहीं है, बहुत ही जनरल क्वेश्चंस है। मगर अगर प्रेजेंटेशन देखी है ना और तुम्हें आज से पहले इसकी नॉलेज नहीं भी थी, तब भी तुम लोग कर लोगे। इट्स क्वाइट सिंपल एंड इजी। पहले मैं देख के तुम लोगों के लिए सिलेक्ट करके रखा है। आ जाओ जल्दी जल्दी गेम ज्वाइन कर लो। चलो लेट्स स्टार्ट द क्विज। एक और बार मैं लिंक डाल दे रहा हूँ लास्ट टाइम। सो वील बी स्टार्टिंग विद द क्विज नाउ। किसी ने अभी तक ज्वाइन नहीं किया तो so we are beginning the quiz. Which binary tree can be implemented using arrays? देखते हैं कितनों ने ध्यान से सुना था। So both complete and perfect binary trees can be implemented using arrays. All right, 11 people have answered it correctly. अगर किसी ने तुक्का भी लगाया होता है, वो होता है ना कि 4 ऑप्शन होते हैं, ऑल ऑफ दीज वाला मारना होता है, वो भी करा होगा तो भी सही हो गया होगा। नाइस। तो अ फ्यू पीपल हैव आंसर्ड इट इनकरेक्टली। ऑलराइट, उत्सव जैन इज ऑन टॉप, followed by Sahil, followed by B1730. Moving on. Next question. What happens if base condition is not defined in recursion? आप लोगों के जपनूर सर ने ये टर्म स्पेसिफिकली बोला था, याद करो अगर एसआईजी में थे तो, कि what happens if base condition is not defined in recursion. ध्यान से सुने वाले, हाँ बिल्कुल बिल्कुल ध्यान से सुने होंगे तो जरूर जवाब दे सकते हैं. स्टैक ओवरफ्लो. 16 people have answered it correctly. कौन कौन यूज करता है भाई स्टैक ओवरफ्लो इन जनरल? +1. us moment. कंट्रोल सी कंट्रोल भी. पेन बड़ी पेन. Okay, so B1730 is on top, followed by Divik, followed by DB. चलो देखते हैं आगे क्या होता है. काफी सारे चेंजेस हो चुके हैं. In dynamic programming, this technique of storing previously calculated values is called. जल्दी जल्दी बताओ. What is the term? In case you have just joined, the game pin is 1905065. So I'll share the link as well in the chat box. So 14 people have answered it correctly. The correct answer is memoization. All right. So moving forward. Okay, Sahil is on streak. Nice. And DB is on top now. So question number 4. Linear data structure in which insertion and deletion operations can be performed from both the ends is called queue, stack, deck, priority queue. हाँ जल्दी जल्दी गूगल कर लेता हूँ, उसके बाद आंसर भी तो देना है. नाइस. All right, so the correct answer is deck. Actually, insertion, both the ends in queue is accessible, but जो फ्रंट एंड है वहां से सिर्फ डिलीशन हो सकता है, एंड बैक वाला एंड जो है उससे इंसर्शन हो सकता है. डेक में दोनों साइड से हो सकता है. इट्स लाइक एन ओपन टनल. So not much change in the scoreboard. Moving on, question number 5. Which of the following is our properties of dynamic programming problems? ये टर्म्स अक्षित सर ने आप लोगों को बताई थी. ध्यान से याद करो क्या थी वो 2 दिक्कतें जिनकी वजह से हमने सोचा था कि डायनामिक प्रोग्रामिंग लगाएंगे. वो एक अंग्रेजी का कोट भी था ना, जिसकी हिंदी कुछ फैंसी सी थी. यस, अच्छा है. नाइस. 19 people have answered it correctly. Both optimal substructure and overlapping subproblems. All right. So moving forward, Divik is on third now. थोड़ा सा change आया है. Let's see if he can surpass Sahil and DB. 6th question of the evening. Choose the correct answer. इसके बारे में भी थोड़ा बहुत बताया था. ठीक है. So let's see who can answer it correctly. काफी कंफ्यूजन होती है कि रिकर्शन यूज करें, आइटरेशन यूज करें. अब बताओ कौन सा यूज करना चाहिए. Okay. All right, so a lot of distribution in terms of the options. So the correct answer is recursion uses more memory compared to iteration. Basically, every time you give a recursive call, एक stack बन जाता है memory में of that instance. So इसलिए उसमें ज्यादा memory required होती है. Simsar is there. Simsar. All right, I've shared the link as well. So which process is used to insert element into a stack? याद करो. Simsar, अरे गीतांश, shout out to Simsar भाई. गीतांश भाई है Simsar. So 25 people have answered it correctly. Great. 3 people have said insert, but the term is push. All right. So moving on. Simsar is going up. Nice. So moving on. Recursion is a method in which solution of a problem depends upon. If you read the options carefully, you can easily answer it, and try to answer it as quickly as possible, because the quicker you answer, the more points you get. And other than this, if you don't know the answer, you can still guess one. So the answer is smaller instances of the same problem. Basically, that's what we call a sub problem. All right. So Sahil is back. Welcome back, Sahil, to the top three. Sims are still on second. Can he make it to the first? In general, the index of the first element of an array is. बताओ बताओ, कहाँ से गिनती शुरू करते हैं? Basic mathematics. So the correct answer is 0. किसी ने 1 दिया है? 2 लोगों ने 1 कहा है. छी 1 नहीं है. Okay. Still Sims are is struggling to become the first. Rajat Sharda is in the top 3. Which of the following property are the properties of leaf node? No faves. अरे सर, आप हो हमारे फेवरेट. जतिन सर, टू लोग. DB is Dhruv Bakshi. Hi Dhruv. All right. Sahil is on third. Simsar second. And on top we have DB, I guess. Dhruv Bakshi is on top. So congratulations, guys. And the fourth and fifth position is backed by Dikhani. All right. So congratulations, guys. Great job. And that's it for the quiz part. Good game. Yeah. So over to you guys, Japnu, Rakshit, Ankush. We'll contact you guys for the prize. Don't worry. We'll contact you guys shortly. Is there anything else you want to ask other than prize? Okay, so we have Ashita ma'am here from IEEE DTU.
Okay,
she'll
hi
be
guys.
taking over.
Yeah, I hope you all like this session. I'm Yeshita, membership coordinator at IEEE DTU, and I will just take a minute to let you all know about IEEE. So right now you attended this 1 or 2 hour sessions on DSA. So IEEE DTU conducts weekly classes on various topics like basic programming, web development, machine learning, and many more. These classes create an atmosphere of learning and consistent learning and growth. Similar to these, we also have internship and placement series for our members. You can check our IEEE placement stats for this year in the link provided. Apart from this, we have various scholarship opportunities too. Additionally, for the students who are interested in research work for future, you will get the opportunity to publish your papers in IEEE conferences and under the guidance of professors who are also an IEEE member. So, lastly, I would say that IEEE is the largest tech society in the world. You can even Google so, and having a PR from this society would shine on your resume. So, winding up, I'm adding the membership form in the link. Looking forward to connecting with you all as members of IEEE real soon. Thank you. I'll just add link. Thank you guys for your time.
हेलो
हाँ जी सर बोलिए।
अरे कौन कौन है यहाँ पर? माइक वाइक ऑन कर लो यार, कोई दिक्कत नहीं है, चिल है। अरे बहुत बढ़िया सेशन किया यार, नाइस।
बताओ सर।
थैंक्स भाई।
आज मैंने थोड़ा लेट ज्वाइन करा, किसी के पास कोई स्क्रीनशॉट है सेशन का?
रिकॉर्ड हो तो रहा है उस पे।
ना उस पे यूट्यूब पे करा है हमने अपलोड, यूट्यूब पे करा है हमने अपलोड।
हाँ
अच्छा,
यूट्यूब पे है, उस पे ले लो।
ठीक है।